Now we're going to do the question 5 here. Use the parametric equations of the ellipse here. X is given like this, y and theta from 0 to 2 pi. Find the area enclosed in this. Look at this. Let us take a look at the table here. So the first will be the angle theta and the coordinates of x and y. When theta is from 0, let us pick some special value, pi over 2, pi, 3 pi over 2. I will export it as a PDF file, so you don't have to write it down, just follow. This is enough. Okay, when theta is equal to 0, then x will be a times cosine of 0, which is 1. Then a times 1 give us a. And y will be b sine of 0, which is sine of 0 is 0, therefore becomes 0. And theta is pi over 2, then cosine of pi over 2. Remember, the unit circle is like this. Cosine axis here. Sorry, different. It is sine axis here and cosine axis here, right? Theta is equal to pi over 2. Then cosine theta will be 0. This is the angle of theta. Cosine of pi over 2 is 0, then x will be 0. Y will be sine of pi over 2 give us 1 right here, which is b, right, at pi here. Cosine of pi will be -1. -1 times a, it will be -a. And sine of pi will be 0. And 3 pi over 2, cosine will be 0, which means x is 0. And y will be sine of 3 pi over 2, which is -1. And -1 times b give us -b. At 2 pi, cosine is equal to 1, right? It will back to a. And sine will be 0, right? So we have the table of the coordinates here. We can graph a picture of this ellipse. If A is like this, is this position, and here is -a, and B is right here, and here is -b, okay? Then the point A0 will be this one, right? The point when theta is pi over 2, it would be 0b, which is this one. And then the next point would be -a0, which is this one. And then 0, -b, which is this one. And at theta is 2 pi, it will go back to a0, this point here. We connect all these points. Right. It gives us an ellipse here. It's not a good one, but you know, right? Okay. And it starts from this point going counterclockwise direction. Okay. We see that. And the question is, use this equation to find the area enclosed by this one. on this area, right? So take a look at the notes I gave you about the section 10.2. We see that this is the y, right? The curve here. Then we know that the area enclosed by this parametric lines is from, if we do in Cartesian's coordinate, it will be twice it is symmetry, right? We can separate this ellipse by two parts. The first part is the upper part where y is positive, and the lower part is when y is negative. Therefore, it is two halves from integral from x is equal to negative a to a of the curve y dx. That is one way, right? Or also symmetry, right? In the upper part here, it is symmetry. We can compute from the blue areas, right? Symmetry. Then the area of this ellipse will be 4 times integral from, this is 0, right? From 0 to a of the curves y dx here, right? There are 2 ways to do it. So we can do either way. Let us pick this guy to compute because it seems to be easier. But look at this. In the Cartesian coordinate, x will run from 0 to a, right? X will run from 0 to a. But in the parametric coefficient, right? Parametric equations, and we want to write everything in terms of theta, right? But in theta variables, right? You see theta, it starts from 0 is this point, a0, go counterclockwise to this point, right? It means that in theta, and in theta, the angle theta, we know that it corresponds to the value of theta. What is it? This point, right? Theta is pi over 2, will be this point. And at a0, the theta will be at 0 here, right? That is why the area of this guy will be the integral from the left to the right, which means from theta is equal to pi over 2 to 0 of the y in terms of theta and dx over d theta. Okay. Is it clear? Okay. Then now y theta is given by this guy, right? And x in terms of theta is given by this guy. So we just substitute here. So it will be integral from pi over 2 to theta, to 0. Okay, let us write it in black letters. Now, y of theta, we just rewrite it. It is b sine theta, right? And we take derivative with respect to theta of x, which is a cosine. And d theta, that's it. integral from pi over 2 to 0, b sine theta, just rewrite it. And what is the derivative of this guy with respect to theta? We can treat a as a constant, and derivative of cosine give us negative sine, right? Which means it becomes negative a times sine theta, d theta, right? So then we write the constant, we can take it out. A and b and the negative sign here are simply constant. We can take it out. It becomes negative a times b integral from, let me write it down here because when we export it to PDF file, it will be a better one. Integral from pi over 2 to 0 of negative a times b, and the integrand becomes sine of theta squared here, right? D theta. So take a look at the trigonometric equations, notes I gave you. Sine square will be, what is it? So sine square here, it will be 1 minus cosine 2 theta here, right? D theta. Just apply this. And what do we have? Let me double check it if it is correct. Okay. Then the constant here, we can take it out, right? It will be negative a b over 2 integral from pi over 2 to 0 of 1 minus cosine 2 theta d theta. The antiderivative of this guy will be antiderivative of 1 give us theta. Antiderivative of cosine, which give us sine 2 theta, right? But remember, when we take derivative back, we know that there is a parameters here, right? Be careful with that. Or you can do substitution slowly. And theta is from pi over 2 to 0. Okay? As theta is equal to 0, it will be negative a b over 2. At 0, it would be 0, subtract 1, half sine 0, right? The first term. Subtract the second terms here, it will be pi over 2 minus 1 half sine of pi over 2 times 2 give us sine of pi. Okay? This guy disappear, and therefore we have negative a b over 2, and here sine of pi will be 0, right? Sine of pi is 0, then this guy disappears as well. Negative pi over 2, right? Negative of negative, therefore we have a b pi divided by 4. Oh, by the way, what we need to do is to do 4 times of this. We forgot this guy is always here before, right? From here. Therefore, it is 4, my bad. Okay, 4 is always here. 4 is always here. 4 is always here. And 4 is always here. Therefore, in the end, it will be A, B, pi. That's it. So the area of an ellipse is given by A times B times pi here. Okay. Does it make sense? Right. Look at this. The area A here, after computing it, it would be A times B times pi. The special case when A is equal to B is equal to R, it will become a circle, right? It makes sense. The area of a circle will be pi r squared. So therefore, we're so confident with this formula. And this is, here we go. We have